In lesson 1, we're going to talk about a couple different things about sequences. We're going to talk about patterns, finding certain terms, and so on. So for our first one here, we want to talk about this sequence that starts with -4 and goes -1, -6, -11, and so on. So if we want to describe the pattern for this sequence, what's happening every time? Well, every time we are -5, -5, -5. So it's the previous term minus 5. So now if we look, if we want to find b of 3, remember, that's just fancy for our third term. So if we look in order, our third term is -6. b of 5, that's our fifth term. Well, we don't have a fifth term here, so we have to subtract 5 one more time. So -11 minus 5 would give us a -16. b of 2 minus b of 1. Well, b of 2 is -1. Minus b of 1 is 4. Now you could either just put that into your calculator, or you could actually do the math, up to you, and you end up with -5. And then if we do b of 5 minus b of 4, -16 minus -11 gives us a -5. And that's going to be our answers to our question number 1. For the second one, sequences do not always need to have an additive or multiplicative pattern. Consider the sequence A of n shown below. 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, and so on. So you can see every 5 terms, it repeats. So therefore, this is going to be a little bit interesting as we get into some of our bigger terms. So if we want to find a of 5, 1, 2, 3, 4, 5, that would be 0. 0 is our fifth term. 13, well, 5, 10. This one goes up to 12, so if we go one more to get to 13, that would be a 6. And then for 2017, obviously we are not going to count 217, but if we divide that by 5, what happens is we get 403.4. So if you think about it, 2015 would give us a perfect ending at the 0. So we are 2 more than that. So that's going to give us a 4. We need to get to the second term. You could also think as 0.4 as 4/10, which really simplifies to 2 out of 5. So we want the second number in the pattern out of the 5, and that would be the 4. For the last one, the sequence of squares shown below follows a pattern until there is no sequences left, or no squares left. Rosie proposes the explicit sequence definition a of n equals 16 minus 2n because she noticed there is 16 squares initially and each subsequent pattern has 2 less squares. Does this sequence represent the pattern? Well, the best way to look at it is plug in a 1. We know the first term in our sequence is 16 because there's 16 squares. The second is 14. The third is 10. 12. The fourth is 10. And then the fifth is 8. Well, when we plug in a 1, we get 14. So therefore, according to the squares, the first term is 16. When we use our formula, we get 14. So the answer is no. The equation does not work. And those are going to be our lesson 1 homework.